Let's look at algebraic fractions. Now, being able to manipulate algebraic fractions is going to be a skill we certainly need to be on top of. When we come to later on down the track, integration, it becomes very important. Certainly the harder extension 2 integrations and so on. So let's just recap. Always factorise first. Before you do anything with algebraic fractions, factorise first. Okay, so the first thing you do is... Oh, well, a couple of people learned. That was very good. Okay, now how to put this into the words, I'm not sure, so I just use symbols. When you're cancelling, people love cancelling. Oh, this goes with this, this goes with this. Once it's all factorised, you only cancel complete parentheses, not bits of them. You don't go, oh, there's an x inside that one, and there's an x inside that one. The whole thing's got to be cancelled. Other than that, it becomes pretty easy. First one, of course, well, we don't have to factorise because we only have one term. This is just one we play cancelling with. So what have we got? 16 on 24 is 2/3. We've got an a cubed and an a cancels, so a squared, b cubed, and so on. So, averages. So, now I'm looking at it and thinking this is a classic algebraic fraction. You're just looking at it and going, hey, that's just a piece of algebra. When we come to a topic called parametrics and we look at the polynomial, the quadratic polynomial, this particular fraction comes up a lot, or ones like it. So the first thing I'm going to do is what? Good, thank you. Factorise. Okay. So on the top, I got a common factor of a, bottom common factor of 2a, but of course I can go further than that. I've still got difference of 2 squares on the top. Now I got p minus q will cancel with the p minus q. They're complete parentheses. And the a, of course, will cancel with the a, giving me p plus q on 2. The average of the parameters, but of course that doesn't mean anything to you at the moment. All right, now for multiplication. So we haven't got single terms. We've now got multiplication. Now, whenever you deal with a fraction and multiplication, what's the first thing you do? Very good. Factorise. Doesn't change. So I've done the easy ones. They don't factorise, so I'll just put parentheses around them to make the cancelling easier. Which one do you reckon I did next? And you can't cheat by looking at the sheet because the sheet's complete. So you don't know which one I did first. Which would you do first? Yeah, I reckon I would have done the difference of 2 squares first. That's got to be the easy one. Sure enough, there it is. 3x plus 1, 3x minus 1. Now, let me show you how we, for want of a better word, cheat. I've now got to factorise 3x squared plus 2x minus 1. Yes, I can go what multiplies together and so on, but if I was going to gamble, I'm going to say it's 3x minus 1 times x plus 1. Okay? What's my logic? Yeah, because they're giving me a question where, okay, in the real world, if there is a real world of maths, I personally believe there is, but in the real world, obviously not every problem is going to cancel nicely. But usually when they give us questions like this, you see cancelling happens everywhere. So there's a really strong chance, well, I've already got the cancelling here with the 3x plus 1. So there's a high chance that 3x minus 1 is going to be a factor of this and so on. And sure enough, yeah, it does. So basically everything cancels and it's just 1. Isn't that amazing? All that algebra, that's just 1. Okay, division. Now, division and multiplication are basically the same, but the only exception is that with division, what do we do first? Good. Still factorise. Mind you, I probably have done 2 steps in one, because once you have factorised, you invert the second one and multiply. So I probably did that all in one hit. And said, right, I know I'm going to turn the second one upside down. I don't need to factorise those 2. I reckon I would have done, because all we've got is a common factor here, isn't it? Yeah, I probably did that one first. There it is. B outside of a minus 2b. I've now got to factorise a squared minus 4ab plus 4b squared. But of course, I don't know whether you noticed it straight away, but I'm looking at that and I'm seeing perfect square. So I know that's a minus 2b all squared, which will cancel with that a minus 2b. We've got a b cancelling, 3s and 6. So there we go. 1 over 2a, a minus 2b. Subtraction is, of course, different to multiplication. Multiplication is lovely because we can cancel the denominator of one with the numerator of the other. We just needs to be top and bottom. Can't do that here because before we can add and subtract, what do we got to do? Yeah, good. Got to factorise first. Always factorise first. Doesn't matter what it is, factorise it first. And there we go. Tops can't be factorised, so I'll just, again, put parentheses on them. Now, before we subtract fractions, whether they be algebraic ones or real ones, what must happen? Yeah, we've got to get a common denominator. When we're dealing with algebraic fractions, sometimes people write common denominators down that are too big. Right? So a lot of people for this one would write down a squared, a minus 1, a plus 1, because basically they say, oh, what's on the bottom there? Just multiply the two things together. And it works, of course, but it will end up giving you more work later on. I just have a simple phrase that I think, and it's if it's not there, put it down. Right? So let me explain. I'm going to create my common denominator. If it's not there, put it down. A. So remember, originally this is blank. So A, oh, it's not there, I'll put it down. A minus 1, it's not there, I'll put it down. A, oh no, it is there. Beaut. A plus 1, it's not there, put it down. There's my denominator. Okay? So I just say, it's not there, put it down. And when you're talking about powers, of course, you need to have the highest power there. So if I had A and A squared, then I would need A squared on the bottom. So then to work out the top, I say, what's different? So I look at the denominator, I say, well, what's different? Well, the difference is I've got this a plus 1. So that's what I multiply the top by. So not there, put it down, compare what's different, and then that's what I'm going to put the top there. So a plus 1 squared. I'll look at the next one. The next fraction I had a plus 1. What's different? It's the a minus 1. So that's what I'll multiply this one by. So it'll be minus a minus 1 squared. Okay? So that's how I deal with addition and subtraction of fractions. If it's not there, put it down, creates my denominator, and then I just go, what's different? And that's what I know what to multiply the top by. Okay, can't cancel because, why? It's not factorised anymore. See, the bottom is, but the top's not. And before you do anything, you got to factorise. So I'm back to now I've got to factorise. Now, there's a couple of ways of factorising this. You might notice we have difference of 2 squares. Okay? So you know it could go a plus 1 plus a minus 1, a plus 1 minus all of a minus 1. You could do it that way. You could expand the whole thing out, of course, and then terms will cancel. Or, way I would do it, I probably didn't here for the sake of the example, but the way I really would do it is I'm looking at this and saying, hey, perfect square minus a perfect square. Basically, the terms are the same, except one's plus, one minus. So I know I'm going to go, one's going to be a squared plus 2ab plus b squared. One's going to be a squared minus 2ab plus b squared. And I'm subtracting. So the a squareds and the b squareds are going to disappear. I'm going to have 2ab minus minus, so plus 2ab, 4ab. So I know the top of this should be 4a. Okay? So as I say, the long way of doing would be expand the whole thing out. But if you notice the pattern, you could just go straight there and go, that's 4a. Okay? Remember, patterns. Maths is all about patterns. And it's fine if you don't spot them. It's just little things that can save time from time to time. One last thing to do. Yeah, cancel the a's, and there it is, our final answer. By the way, why do we factorise? Well, I mean, I haven't bothered expanding the bottom out. Why do we prefer something factorised? Or, let me ask another question. Why do we simplify algebra? What does simplify mean? Say it again. To make what easier? Yeah, I think we're on the right track. To make the eventual substitution easier. Because remember, the pronumeral is representing an unknown. So it might be a formula, or it might be something like that. Eventually down the track, you would think you would substitute a number into that unknown. So look at the original question. Look at our final answer. Well, what's going to be easier to get an answer for? If I know what A is, I'm going to substitute into that. It's going to be very easy. Sub into the first line. Sure, I'm going to get two numbers, but I've still got to do a subtraction and so on and so on. So that's what simplify means. Make this easier to substitute into, basically. Oh, 3 fractions, eh? Okay, not a problem. Mere mortals might quiver, but us super mathematicians, not a problem. What's the first thing I'm going to do? Yeah, almost thought it was, but look at the last one. X squared minus y squared. So let's turn that into x plus y, x minus y. If it's not there, put it down. X plus y squared, put it down. X minus y squared, put it down. X plus y, well, it's there because it's inside the x plus y squared. The higher power is the one you want. X minus y, yes, it's there. There's my denominator. What's different? X plus y squared, so that's going to become x minus y squared. X minus y squared changes x plus y squared. This one then will be minus twice x plus y, x minus y. Again, you could expand the whole thing out, and I probably did in the worksheet, but if we're clever, we should be able to work this out. We've got an addition here of 2 perfect squares. So now it's going to be the middle term that's cancelling. So I'm going to have 2 lots of x squared and 2 lots of y squared. But I am going to subtract 2 lots of the difference of 2 squares. So I'm going to subtract 2 x squared minus y squared. So what did I have? I had 2x squared plus 2y squared. I'm going to take away 2x squared, but then minus minus. So I should end up with 4y squared if I've thought through that correctly. Let's see what happens. So there's the long way. Expand the whole thing out. And yes, we ended up with 4y squared. Okay. So if you're lucky and they've given you nice numbers, that can save time. Otherwise, remember, if you're spending too much time looking for a quick way to do something, then you may as well do it the long way, because that might end up being quicker than looking for the short way. All right, 1D.